Today, day 3 is fun day and we will do dots, figures, lines and we will count them too. Great. So, we were on square numbers with dots in the previous session. So, we did dots and the square numbers. Today, we'll start with very amazing numbers and numbers with the dots again. Let me have this dot board open. Look carefully and then tell me what kind of numbers are these. If I put a dot, what do you think about this? Which number this dot represents? Yes, anyone? One. Very good. Now, what is 1? 1 is 1. 1 into 1 is 1 again. 1 into 1 into 1 is 1 again. If you keep on multiplying 1 with 1, you will always get back 1. And you know, that's why one dot can be said to be any kind of number. It can be a natural number. It can be a whole number. It can be a square number. It can be a cubic number. Cubic number means when three same number are multiplied 3 times. When a number is multiplied by 3 times, then it is known as cube number. That is 1 into 1 into 1 is 1. Like 2 into 2 into 2 is 8. 8 is a cubic number. So that means this 1 represents any kind of number, be it picture or with integer. Okay, now see what I'm doing. I'm adding 2 more dots. Now, what kind of figure you see?
Triangle.
Triangle. Very good. Now, I am adding 3 more. Again.
No, again
Triangle.
triangle.
I am adding 4 more. Again a triangle.
Triangle.
Correct. Now see. Let me have some space. Now if I add 5 more, again I'll end up getting a triangle. I'll add 6 more. I'll again end up getting a triangle. You know, these kind of numbers are known as triangular numbers. Why they are known as triangular numbers? Understood? Because whenever they are like plotted on a graph paper and whenever we keep on increasing the numbers by 1 to it. Now what do you mean by increasing the number 1 to it? Just see. First I have 1 dot only. Then I added 2 more dots. That means 1 plus 2. 1 was a triangular number. 3 dots are also triangular number. Then I add 3 to it. That becomes 6. And you know 6 is a triangular number. Okay, I have taken 1 and then I add 2 more. So 3 is a triangular number. Then I added 3 more. 6 are the triangular numbers. Then I added 4 to it. 1 plus 2 plus 3 plus 4. That is 10. 10 is also a triangular number. Now with 10, if I add 5, one more base, and then again it becomes a triangle. That means 15 is also a triangular number. Again if I add 6, 15 plus 6 is 21. Again these all are triangular numbers. These are known as triangular numbers. Okay?
Yes, sir.
Yes. So we did square numbers, we did prime numbers. Now is triangular numbers, and you can keep playing with this. 1, then you add 3 to it. Let's see the square number formation with dots once again. 1. I know 1 is a square number also. 1 is a square number. Great. Now I am adding 3 dots. So 1 plus 3, that gives me 4, and this is 2 into 2, another square number. I am adding 1, 2, 3, 4, 5, 5 dots. That means 4 plus 5 is 9. That is another square number. Now, how I am increasing dots? I am increasing dots either on the left hand side or on the right hand side, and on the top or the bottom. Okay, so I can increase like these two. I am increasing one column on the left. 1, 2, 3, 4. And then a row at the bottom. 1, 2, 3. So I added 7. 9 plus 7 is 16. Again you can see it gives you a square. So these numbers are known as square numbers because when plotted on a dotted graph pattern, they give us a square. A square is a bounded figure such that its length and breadth is same or all sides are equal. Those are known as square numbers. You can draw pentagon numbers, hexagon numbers, anything on the graph paper, and these all are known as polygon numbers. A polygon is something which is bounded and will have minimum 5 sides, all enclosed. The minimum bounded figure, if we talk about bounded figure, this smallest or the smallest bounded figure is a triangle with 3 sides. Then we have something like 4-sided figure which are known as quadrilaterals. Now quadrilaterals are of many types. Parallelograms, squares, rectangles, all are quadrilaterals. They have got 4 sides, and when we have more than 4 sides and we have an enclosed figure, we start calling them polygons. Now 5-sided polygon is known as pentagon. Okay, like American headquarters, Pentagon, 5 sides. Okay, so if we have 6 sides, what should be the name given to the 6-side one? Hexagon. 7, septagon. 8, anyone? Octagon. 9, nonagon. Yanenogon. Nonagon. And the 10th one with 10 sides, Decagon. Decagon. Okay, so we have triangles, quadrilaterals, pentagons, hexagons, septagons, octagon, nonagon, yanenogon, and decagon, and on and on and on. Fine. So these are known as polygons. We will see how we can count number of triangles in triangles, how we can count squares, and how we can count rectangles. So, how many square you can see? Very good. 1. Okay. Now this time what I am doing, I have a big square, and in this I draw these 2 lines, and such that inside also I can see there are 4 small squares. So how many squares are there now? 5. Brilliant. Very good. 1 is the bigger one, this big square, and then we have 4 small. 1, 2, 3, 4. So 1 plus 4 is 5. Very, very good. Now let's take a bigger square. Now this time I'm going to give you a tough thing. Now I have 9 small squares inside it. Anyone who can count that how many squares now we have in total? All sides are equal. 1 for the outer one. Then 2 into 2, 1 is square. Again, this is also 2 into 2, another is square. This is 2 into 2, third, and this one is fourth. So plus 4. And then we have small, 9 of these. 14 squares of different size I can see. Okay, now you want to know the trick that without actually counting, how we can count the number of squares on a square board? Suppose I have a square and inside the square I have 4 columns which are of equal width. Then I have 4 rows which are of equal length. That means each side is of equal length. Now I can see this is 4 into 4 is square. What we call this? 4 into 4 is square. Square board or checker board, whatever name you feel good for you. So if it is 4 into 4 is square board, now see how to find just by using a mathematical fun formula that number of squares in this particular checkerboard are simply, it is 4 into 4. We will always start with 1. 1 into 1. Then we will add 2 into 2. We'll add 3 into 3. And we'll add 4 into 4. And we will stop. Why we have stopped here? Because the maximum number of small squares what we can get is 4 into 4. Now we need to just find the values and then add up. 1 into 1 is 1, 2 into 2 is 4, 3 into 3 is 9, and 4 into 4 is 16. 16 plus 9, 25, plus 4, 29, plus 1 is 30. Believe it or not, without actually counting, you are counting the number of squares. Isn't it interesting? So check out yourself what is there, but it is a square checkboard. You need to count the number of rows and columns and be sure that both are same, and then apply the formula and give me the answer quickly. Fastest finger first. I want to see the answer in the chat box. Yes, let's check. So we have 1, 2, 3, 4, 5, 6. 6 columns. 1, 2, 3, 4, 5, 6. 6 rows. That means it is a 6 into 6 square checkerboard. Isn't it? Yes. So, $91. So just concentrate on the blue diagram first and leave the red one. Forget that there is anything in red color on your screen. Just concentrate on this. What is this? This is a 4 into 4 checkerboard, isn't it? And how many squares are there into 4 into 4? We know that. 1 into 1. In this particular figure set, we have got 40 squares. Understood now? You want to do one more? 4. 5 plus 1 is 6. 9 plus 2 is 11. Bingo. Yes, this time all of you are correct. Now create your own diagrams and try to count it. Okay, let's increase our level. One, 2, 3, 4, 5, 6. And here we have 1, 2, 3. Okay, so we have 6 columns and 3 rows now. Oh, in the previous one, what we have? We had number of columns and number of rows were same. But here, number of rows and number of columns are different. Are you getting this? Number of columns, number of rows. This time these are different now. Now see how to do it and see carefully. Now there are 6 columns. I will write 6, 5, 4, 3, 2, 1. I'll keep on writing the numbers in the decreasing order till I reach 1. Now how many rows do I have? I have 3 rows. In row column, I will start with 3, 2, 1. Good. I hope this is clear what I am doing. Now multiply horizontally. Multiply horizontally. 6 into 3, 18. 5 into 2, 10. No need to multiply. Why? Because we have got 0 here, nothing here. And something into 0 will always end up giving us what? 0. 0. So no need to calculate this. Now just add up. 18 plus 10, 28 plus 4, 32. There are 32 squares in this diagram. Understood? So this is 7 into 4 checkerboard. Find number of squares on this checkerboard. Take your time and give me correct answer. What? I have columns, I have rows. 7, 6, 5, 4, 3, 2, 1. Rows 4, 3, 2, 1. Wonderful. 7 into 4, 28. 6 into 3, 18. 5 into 2, 10. 4 into 1, 4. 16, 4, 20, 40, 50, 60. Bingo. Wonderful. Great. Now let me show you some counting technique with triangles also. I hope in the diagram you can see 3 angles. Now look, level 1. How many triangles you can see here in this red one? 1. Good. Now one more triangle. Now look carefully. From one of the vertex, let it be A, B, C is a triangle. From one of the vertex, I am dropping a line on the face which is just opposite to the vertex. These all heads are known as vertices or vertex singular. Okay, so from one of the vertex, I have dropped a line on the base. Clear? Now how many triangles you can see? 3. Correct. One is triangle ABC. You can see triangle ABC. Yes. Now if I mark this D, then I will have ABD, another triangle, and then I will have ADC, another triangle. That means now I have 3 triangles in this figure. Okay. But if I keep on dropping lines from this vertex on the space in different angles, then would it be easy for us to calculate the number of triangles? Let's see. Let's see how to do that. Okay, it is fun. Just see and make a note of this properly. This is a triangle. Now from one of the vertex I am dropping one line and one more line. Okay, so now can you tell me how many triangles you can see in this figure? First, this smaller one, this smaller one, this smaller one. So 3 red dots, correct? Then 1 orange dot, the outer one. Now look carefully for the blue one. Isn't this is also a triangle? Yes? 1. Isn't this also a triangle? 2. That means we have got 2 more. Add up. 1 plus 2 plus 3, 6. Actually, there we have 6 triangles in this particular diagram. Now see how to count. Just we will count the number of small triangles on the base and we will number it. Now see how to number it. This is 1, this is 2, this is 3 and this is the 4th smaller one, isn't it? This is the first smaller one, second smaller one, third smaller one, 4th smaller one on this base. And now the magic. Now how this magic is? Now total number of triangles could be just 1 plus 2 plus 3 plus 4 and yes, we are done. There are 10 triangles. Count. Give me number of triangles. 3, 4 and 5. So 1 plus 2 plus 3 plus 4 plus 5 is how much? 15. Wonderful. You have passed level 1 of triangles. Now we are moving into level 2 of triangles. See, this is a triangle and we know this is our triangle. We can see only one triangle here. Okay. Now, if I am dividing this or drawing a parallel line to one of the bases, I put a cut here or maybe like a paper fold here. You were learning or paper folding things now today before the class. Suppose I put a fold here and after folding I bring it back. Now tell me how many triangles you can see in this diagram. One bigger one big triangle and one small triangle, isn't it? This is the bigger one, and this was the smaller one, 2. So we can see how many? 2 triangles. Okay, now I will show you the trick and it is very easy. Let me give you the trick and then a tough question. Just see how to count with the parallel lines. First, in level 1, we did with what? We did with vertical lines from the vertex. VV. Now we are doing parallel lines to the bases. Suppose one parallel line I have drawn and then I have one more and I have one more. Then how many triangles you can see? Just count the parallel lines and see the fun. 1, 2, 3 and also count the base. 4. So how many parallel line and the base you have counted? 4. 1, 2, 3, 4. And you know the magic? Yes, the magic is here we have only 4 triangles. Here we have only 4 triangles. 4 triangles only. 4 triangles only. They are not 5, they are 4. Just see. Small, number 1. Then number 2. Then number 3. Then number 4. So, with vertex, we keep on adding. With parallel lines, we just count. Now, do you mind if I add both of them? Count the number of triangles. Yes. Now let me show you. Whenever you have this complicated both side something like this, what you do, you just separate them. This is from the vertex diagram and this is for the parallel to the basis diagram. Just count the number of triangles in this particular figure and we know how to count. This is 1 plus 2, that is 3. Now count the number of triangles in this particular figure and we know that we need to just count 1, 2, 3. And you know what is the answer? Answer is always we need to multiply these two counts. 3 into 3 is 9. We have got 9 triangles on this figure. I know you will be giving me correct answer. To try, let's separate them. Parallel one. We have the vertex and the vertical line. Parallel ones are always the count. 1, 2 and 3. And for the vertex and the verticals, we have to add up 1, 2, 3. 1 plus 2 plus 3 is 6. So final answer 3 into 6, 18. Wonderful. I hope you have enjoyed learning number of squares when it is a square board. You love learning how to find number of squares when it is not a square board. Number of triangles when we have vertex and vertical lines. Number of triangles when we have parallel lines to the bases. And believe me, they can ask you anything by combining these diagrams also. So, still, once again, for squares in squares, what we do? For squares in squares, what we do? We do simply 1 into 1 plus 2 into 2 and on. For squares in rectangles, what we do? We list down rows and columns and then multiply. For the triangles, vertices, for the triangles from opposite vertices, if you draw vertical lines, what we do? We add like 1 plus 2 plus 3 on the bases. And when we have parallel lines to the bases, we just count 1, 2, 3. Okay? So hopefully you have made proper notes. Go through it, enjoy it, and that was figure counting for today's session. Thank you everyone.